Okay, so looking at 2023, paper 1, 9a and 9b, part 1. Ava's investigating factors of different numbers. First, she looks at numbers that can be written as powers of a prime number. List the 5 different factors of 2 to the power of 4. Can you write each one as power of 2? So I think an interesting place to start is asking ourselves, well, what is that number 2 to the power of 4? So we probably don't need a calculator for this. We know that it's 2 by 2 by 2 by 2. So 2 by 2 is 4, by 2 is 8, by 2 is 16. So the number is 16. So what are the factors of 16? Well, 1 divides in. 1's a factor of everything. 2 divides in. 4 divides in. 8 divides in. And 16. So there are 5 factors that we were asked for. Now, it does say you can write each of these as a power of 2. So 1 is 2 to the power of 0, 2 is 2 to the power of 1, 4 is 2 to the power of 2, 8 is 2 to the power of 3, and 2 to the power of 4 is 16. So I suppose the one to remember there that you might forget is that to get 1, it's always 2 to the power of 0. It's always whatever number to the power of 0. Anything to the power of 0 is 1. Okay, work out how many different factors 3 to the power of 7 has. Now, we can go into detail with this one, or we can kind of look at what we've done before. So when it was a power of 4, we had 5 factors. So if we've the power of 7, we should really be expecting 8 factors. Now, let's say we didn't know that. Well, let's follow the same idea. So we're expecting 3 to the power of 0, 3 to the power of 1, 3 to the power of 2, 3 to the power of 3, 3 to the power of 4, 3 to the power of 5, 3 to the power of 6, 3 to the power of 7, mimicking what we've done before. Now, what is 3 to the power of 7? So let's check that out. So that is 2187. Now, 3 to the power of 0, remember, is 1. Does 1 divide into 2187? Absolutely. 3 to the power of 1 is 3. So does 3 divide into 2187? Well, let's see. It does. And 3 goes in 729 times. And obviously 1 divides in 287 times. Okay, 3 squared is 9. So does 9 divide in without remainder into 2187? Okay, so it does, and it goes in 243 times. What about 27? So 2187 divided by 27. So that's 3 cubed is 27, and that goes in 81 times. Now, when we do 3 to the power of 4, we get 81. Because factors occur in pairs, we've already found each of the pairs, so we don't really need to continue because we're just going to get 81, 243, 729, 2187. So we have the pairs, and indeed, if we count them, there's 1, 2, 3, 4, 5, 6, 7, 8. So just like we predicted, there are 8. Work out how many different factors of 2 to the power of 10 and 3 to the power of 12 has. Okay, well, looking at the idea from earlier, we would expect this one to have 11 factors. Why? Because it's a power of 10, so we expect 11 factors. Here we have a power of 12, so we're expecting 13 factors. Now, how many different factors 2 to the power of 10 times 3 to the power of 12? So we'll multiply 11 by 13, and we get 143 factors. So that's what we're expecting. And then B part 1, oh yes, so this is just, we fill out the pairs. So again, it's basically what we've just done. If X is 1, Y is 12, because 1 by 12 makes 12. If X is 2, Y is 6, Y, because 2 times 6 makes 12. That one's done for us already. 4 by 3 would have to be 12, 6 by 2 would be 12, and 12 by 1. Now we're repeating the pairs there, but that's just because we're using it to plot the points. And then we plot the points, and I won't continue then because that's a little bit different down there, but that's just factor work, which we did last year.